100 milliliter of liquid water at 90 degrees Celsius is added into 150 milliliter of water in a calorimeter at 15 degrees Celsius. The final temperature is 40 degrees Celsius. Calculate the calorimeter heat capacity, knowing the specific heat of water is 4.184 joules per gram per degree Celsius. Alright, so we're dealing with a calorimeter, and any calorimeter now can be looked at as an insulated system. And for any insulated system, as we already learned, always has Q loss plus Q gain equal to 0. And that means in this system, whatever heat that objects lost must be absorbed by other objects in the system. And our first priority, of course, is to look at the system, identify how many objects are in there, and then for each of them, whether they're losing or gaining heat. So let's see. The first object, of course, is our 100 milliliter of water. This is hot, 90 degrees Celsius, and since final temperature is at 40, apparently our hot water has lost heat. So hot water losing heat. There are no other hot objects in the system, so this is the only thing that's losing heat. Now, who's gaining? No doubt, the 150 milliliter cold water will be absorbing heat. But is it the only object that's absorbing the heat that's released by hot water? Well, there is the calorimeter. And in some of the examples that we've seen before and some of the calculations that we did before, we ignore the container, see it as the part of the environment, but not in this one. We're required to calculate heat capacity of the calorimeter. That is saying the calorimeter is part of the heat interaction. And since the hot calorimeter is holding the cold water at 15 degrees Celsius and its temperature did go up to 40 degrees Celsius, we can draw the conclusion here that the calorimeter also gained heat. And how much? We don't know, because we don't have the heat capacity, but it's definitely part of the Q gain. And that's all the objects in our system. So Q hot plus Q cold plus Q calorimeter should equal to 0. Okay, for each of them, now that we established what are they and what did they do, how do we break them down? So for the two part of water, hot water and cold water, we know Cp. So you know which equation to use. It's got to be mCp delta T. For the hot water, mCp delta T for the cold water. But notice the m are going to be different, and the delta T are going to be different as well. The only thing that's common for the two parts of water is the specific heat, Cp. And then, of course, calorimeter. How do we break down calorimeter? Well, we want heat capacity, which is C, and of course that would be C delta T. And what's the result broken down? We can stick the numerical conditions that we have into the calculation. 100 milliliter of hot water That's 100 gram. Because water is 1 gram per milliliter. Cp is 4.184 joules gram degrees Celsius, so gram cancels. And delta T is final temperature. All final temperatures are 40 degrees Celsius minus initial temperature. (90 degrees Celsius). So degrees Celsius cancel, and this should be ended in joules. Cold water, 150 milliliter is 150 gram. 4.184 joules gram degrees Celsius, gram cancel, and delta T would be final temperature 40.0 degrees Celsius minus initial temperature cold water 15 degrees Celsius. Degrees Celsius cancel, joule unit. And then the last part, C of the calorimeter is what we want. Delta T, the calorimeter has the same delta T as the cold water. 40 final degree temperature, 40 degree final temperature, 15 degree initial temperature, degrees Celsius. And total of that equal to 0. Put your numbers together, rearrange the equation. We got 25 degrees Celsius times C equal to, move the number to the other side, 5230 joules. And of course, calculated C, the calorimeter heat capacity, should equal to 5.0, keep our 3 sig fixed, 209 joules per degree. So really, it doesn't matter how many objects that we have in the system, as long as we can identify all of them, don't miss anyone, as long as we can make sure that we know whether they're losing or gaining heat and break them down correctly, like what we did here. Eventually we can do our calculation, and the process might be a little complicated with more objects, but carry your units in there, make sure things cancel right, make sure you don't switch place for your initial and final temperature. We should be alright.